All right, let's talk about something every single one of us has felt, but maybe don't fully understand: pain. We're going to follow the incredible, secret journey of a single pain signal as it travels through your body. And trust me, it's a fascinating story that reveals so much about how we work.
Because really, that's what it is. It's not just a feeling, it's a whole narrative. It's a biological drama of detection, transmission, and most importantly, interpretation. So let's dive in and see where this story begins.
So, first things first. At its most basic level, pain is actually a good thing. I know, it sounds weird, but it is. It's this vital, highly evolved alarm system. Its whole job is to protect you, to yell at you when there's danger so you don't cause even more damage. Think of it as the smoke detector for your body.
And you can really see the two sides of this alarm. On one hand, you've got acute pain. That's the alarm working perfectly. You touch a hot stove, it screams, you pull your hand away. Done. But on the other side, you have chronic pain, and that's when the alarm itself is the problem. It's a faulty system that's just stuck in the on position, ringing long after the danger's gone.
Now, to really get why that alarm can break down, we first have to follow the path of a healthy one. So let's actually trace the journey of a pain signal, right from the very moment of impact.
The whole story starts with these things called nociceptors. They're basically tiny little sensors, specialized nerve endings scattered all over your body, and they're just waiting for anything that could cause damage. Intense pressure, extreme heat, you name it. As soon as they're triggered, bam, they translate that physical event into an electrical distress signal.
And what's really cool is that this signal doesn't just take one road. It actually takes two different highways to the spinal cord. First, it zips down the express lane on what are called A-delta fibers. They're super fast, and they deliver that initial sharp ouch moment. But right behind it, traveling on the slower local road, the C fibers, comes that second wave of pain. You know, the dull, throbbing ache that lingers.
And this is where our understanding has really changed. For a long time, we thought the spinal cord was just a simple cable sending messages up to the brain. But it turns out it's way more than that. It's a dynamic processing hub. It can actually amplify the pain signal or turn it down or even distort it. This is where the plot really starts to thicken.
Which brings us to this really groundbreaking idea called the gate control theory. Have you ever wondered why, when you bump your elbow, the very first thing you do is rub it? Well, that's not just in your head. There is a real neurological gate in your spinal cord, and by rubbing it, you are actively helping to close it.
So here's how that works. The pain signals are trying to push open the gate to get their message to the brain. But other sensations, like touch and pressure, they travel on different, even faster nerve fibers. So when you rub that elbow, the touch sensation literally gets to the gate first and activates neurons that slam it shut, blocking the slower pain signal from getting through. It's like creating a traffic jam where only one kind of car gets to pass.
Okay, so let's say the signal makes it through the gate. It then travels up to headquarters, the brain. And here's the crazy thing. There's no single pain center in your brain. Instead, that signal lights up a whole network of different regions all at once, something we call the pain matrix. Each part of this network has a totally different job. You've got the somatosensory cortex, that's kind of like the GPS. It pinpoints the location and the intensity. Sharp pain, left big toe. At the exact same time, your emotional centers are processing how unpleasant it is. This is awful. And then your prefrontal cortex, the thinking part, jumps in to add context and worry about what it all means. And this overlap is just profound. The brain processes the physical ouch and the emotional this is terrible in the same interconnected areas. This is exactly why there's such a powerful, well-known link between chronic pain and things like depression and anxiety. The circuits are so intertwined, one experience can easily make the other one worse. So, what happens when this incredibly intricate system goes wrong? When that alarm doesn't just ring for too long, but it actually starts to rewire itself to be more sensitive? Well, that's when we enter the world of chronic pain.
A key process here is something called central sensitization. The best way to think about it is like a car alarm that's just gotten way too sensitive. You know, at first it only goes off if someone actually tries to break in. But soon a gust of wind sets it off, then a cat walking by. Eventually, it's just screaming for no reason at all. The nervous system gets stuck in this high-alert, wind-up mode, where it overreacts to everything.
This sensitization leads to two really bizarre and debilitating things. The first is hyperalgesia. That's when something that should hurt a little ends up hurting a ton, like a small paper cut feels like a major injury. But even stranger is allodynia. That's when you feel real, intense pain from something that shouldn't be painful at all, like the gentle touch of a cotton shirt. The wiring has just gotten completely crossed.
Now, if you want to understand just how critical it is to control that initial acute pain, you just need to look at this one number, 30%.
This is staggering. This data comes from a major study on post-surgical pain, and it shows that for every 10% increase in time a patient spends in severe pain right after surgery, their risk of developing chronic pain a year later jumps by 30%. This tells us that poorly controlled acute pain isn't just unpleasant, it can physically change the nervous system, kickstarting that whole sensitization process.
But look, this isn't all bad news. Not at all. In fact, because we understand this entire journey from the sensor all the way to the brain, we're actually finding much, much smarter ways to manage pain.
And here is a truly remarkable part of the story. The brain isn't just a passive victim here. It can actually fight back. It has its own powerful built-in system for controlling pain, a system that sends signals down the spinal cord to intercept the incoming alarm. This is our top-down control over pain. A command center in the midbrain can actually send signals down to the spinal cord that basically order that pain gate to close. And what influences this command center? Well, our emotions, our focus, our expectations. This is the real science behind how things like mindfulness or distraction or even the placebo effect can provide very real pain relief.
So this deep understanding of the whole pathway has led to a much smarter way to manage pain. Instead of just looking for one single magic bullet painkiller, doctors now use what's called multimodal analgesia. It's all about intervening at different points in the pain journey, blocking the signal where it starts, closing the gate in the spinal cord, and changing how the brain interprets it, all at the same time.
Which really leaves us with this final thought. Pain is a story that's written by our biology, but it's edited by our psychology. So as we look to the future, are the best solutions going to come from a pill that targets the signal, or from therapies that help us change how our minds interpret the message? The answer is probably a combination of both, reminding us that the experience of being human is never just one thing, but a complex and fascinating network.